Welcome to another GC Basic tutorial. This is a tutorial for the 18xxQ20. Introductions. My name is Venn. I'm the lead developer at GC Basic, and I want you to like the video, watch the video all the way through, and subscribe to the channel. It will help fund the open source project, as open source projects are not free. Wait also to the end of this video, and we'll going to toggle out and change out the programmer to show you how to change the programmer. Currently, I'm using a PIC18xxQ20. Let's just get into the video. Right, so what we've done so far, we've made some LEDs, come on and off, we've sequenced them, we've used the ADC, we've used a switch. Well, we're going to put this together in one sequence, and when we push the button, they're going to travel in reverse. So they're going to go backwards and forwards. And it's pretty simple. And then the next video, we're actually going to put all the values of that onto the serial terminal, and it's most insightful. But I didn't want to do that too early because you need to understand the build process of how we got to this. But serial is the next step. What I've got is a prototype board. It's got the equipment laid out as per the diagram on the right hand side, powered at 5 volts, PIC18 at the moment. I've used a PIC18 in some of the videos. There's some LEDs and resistors, and they're connected to port C, 7, 6, 5, and 4. There's a potentiometer on port A0, and there's a switch on A3. And what we're going to do is we're going to put it all together. We're going to have the LEDs rotating in sequence. They're going to go in one direction, then the other. When you push the input, the switch, we're using the switch as an input, not as the master clear. We're going to take the ADC, read the voltage from the potentiometer, and then we're going to scale it between, I think, 1 millisecond and 1,000 milliseconds. And then we're going to have a weight based upon that value. So we're putting it all together. What does that look like in terms of a process flow? I'm going to initialize the chip. GC Basic will do all that for you. Flash an LED. It's going to do a forever loop forever, but it's going to read the ADC, and depending upon whether you push the switch, it will go left rotation or right rotation. Extremely simple. Let's have a look at that in reality. We'll actually go to it straight away and we'll see it working. Look, these are the LEDs I've got working. This is the potentiometer here. If I rotate the potentiometer, it goes faster and faster until it goes to 1 millisecond. And then I rotate it, it goes out to 1 second per change. Here is the Q20 sitting here. Q20 is connected via this flying cable into a PIC18, which is laying here. I'll pull that out later. What else? I got power on the board of 5 volts, and these leads just connect it through a back plane that is actually not, you can't see, but I'll just zoom out on that. There's the back plane over there. And so you've got a way of connecting this up. Pretty simple stuff. There we go. Let's just leave it like that and line it up. We'll go back to the program. So let's have a look at the sample code. Here is the IDE as we left it. Control B will give me a list of all the files we're working on, and I want file 90 now. There's file 90. Control B to shut that outside window. Remember, Control J, well, there's many different ways of opening up the bottom window as well. Control J is the one I use. I think Control single quote does the same. It does. There you go. But Control B opens up the side. Let's open up the side and we'll look at some other stuff. Outline. There's a thing called outline here. And if I wanted to see the outline of my program, this is the part I'm using. These are some constants, some variables, some settings, and there's a function at the bottom called function press key. So as you come through your program, these are actually laid out for, so you can find components within your program very simply just by clicking on them, and you'll get taken to that particular area of the code. Right hand side, you've got what's called the crumbs. You can actually do the same over here. Look, you can cursor through the program at high speed, and it's color coded so you can find your functions and etc. And notice GC Basic and this particular IDE is highly color coded so you can find and learn from the system. Control B. Get rid of that side window, and we'll shut the outline down. Look at our program. I'm going to fold the whole program so we can just walk through it. Control A, function key F2, fold all. You can just type fold all, but I've already done it, so I can just select it. And this is the complete program. Chip is a 18F16Q20, and you've seen that before. So let's unfold pieces. This is the port layout, which you've seen. Great. I'm not going to spend any more time on that. We define some constants to make things easier. You've seen that before. These are the constants to define the port that we're using and each of the LEDs and where they're assigned to. And why we use constants, because it's faster to manage. Set the ports as an output, define a constant for the ADC and set that as an input, and then define a switch. And we call it switching. And we're going to use that constant within our little routine, our little function. And that's essentially the board setup. The main program has two variables set up. One's called direction as a bit. And if it's set to one value of 0, it will go in one direction. If it's set to 1, it will go in the other direction. My delay as a word variable is going to store our ADC value between 1 and 1000. So it has to be a word because the range of that is greater than 256. I have some control constants. Define LED right and left. They're either 0 or 1, and I spoke about that. So if it's moving in the right direction, we can set the direction variable bit to 0 or 1, which will equate to LED right and LED left. Set the start direction as left. So what I mean by left is it's going to shift the value of port C to the left and then rotate that around. And we saw that in a previous video. First, we just need to seed our little system. So we're going to set LED 4 on, and then it will just rotate into LED 5, 6, and 7, then come back to 4 if it's going to work. Let's look at our do loop. And in the do loop, we get the value of the ADC port, we set the LEDs, we wait and check this to see if the switch has been pressed. And if once those three things have been done, it just goes back and does it again. Slowly walking through. Get the value from the ADC port. I've seen this before. It's going to return a value between 0 and 1023. Well, I've already explained you don't really want to put a weight of 0 out, so we just scale that up to 1 millisecond to 1000. You can change that and do what you like in there. I'm going to set the LEDs. Well, if the direction is left, LED left, it does one thing, else it does another thing. So what's it going to do? Well, if it's going left, it rotates port C, which equates to LED, the constant LED port. It will move them to the left. So it will go to the left one step, to the left one step. And there's a PowerPoint presentation that you can download to see that happen interactively. And when the carry equals 1, we know we've gone to the 9th bit. We can now reset LED 1 and just carry on. But what happens if it was set to LED right? Well, might seem strange, but if it's you obviously do the rotate to the right, but the reset is slightly different. So if LED 4 equals 1, you just need to turn it off and then set the 9th bit on, which is called set C. And so you remember C is the 9th bit. And so if you're moving to the right on this particular chip, you don't really want to set port C.3 to anything. Leave it alone, okay? And we'll touch on that later in a much later video. But if it's gone 7, 6, 5, 4, the next one you can set it to is set the 9th bit and then rotate everything, and LED 7 will come on automatically because that's the carry flag. So LED 4 equals 0, set the carry flag, and then rotate everything, and it all works fine. You need to get your brain around that. Look at the previous video. Then we do a wait and check if the switch has been pressed. So we wait my delay. Remember, my delay was what we set between 1 and 1000. So that will be a wait of 1 to 1000 milliseconds. And then we say, if the function key, if the key has been pressed, if it's equal to true, then change the direction. So direction equals not direction is equivalent to, if it's 1, set it to 0. If it's 0, set it to 1. And that is our program. Down here, we've got the function, which you've seen before, and you can look at that in your own time. So let's just program that out. Function, I'm using function key F5 then to compile it up. Great. And it's programmed it. And if we look at it, desk cam, it's done it. Now, how can I prove to you it's done it? That's an issue. Let me go back to the desktop. PIC18xxQ20. We're going to erase the chip and then do it again. Erase the chip. Function key F5. You can see it start here. And then at an appropriate moment, downloading. It's not doing anything. Desk cam is running. We can now come into here and change the value. And here we go. Let's go backwards and forwards. Push the button. I'm going to put it at a pace. There you go. Brilliant. It works. It just works. So what I've done is walk you through the code. But we're going to look at some other things that I've done. I wanted to show you as well. Let's just go into, let's change the programmer. That's what I wanted to show you. Desk cam. Let me zoom out. I think a bit of a zooming out might help here. Move that to the right. There we go. PIC18xxQ4, not connected. As I said, there is a PIC18xxQ2 connected here. Now, there is nothing connected to this now. I'm just going to put the PIC18xxQ4 into here and just drop that back over there. So nothing's much changed apart from the fact I've changed to a PIC18xxQ4. Okay. So I'm expecting it to work. It's powered because we can see the LED is on. And if you're worried about why this is pink here, that's color coded. And if that goes black, I know the board's getting hot. Just thought I'd share that with you. Right, into here. Function key F4, prefs. Edit the preferences. Now, previous to this, I've installed MPLAB X, MPLAB X, yes, MPLAB X, and in MPLAB X, there is a programmer, and that programmer is called IPE, and that will control the PIC18xxQ4. You can install MPLAB and just the IDE part piece, or you can install the IPE, which is the programmer, integrated programmer environment. And inside of the preferences, you will see different types of programmers. And I've got just attached a PIC18xxQ4, and I just want to drag PIC18xxQ4 CLI, command line interface for PIC. I'm just going to drag that to the top. And now it will use MPLAB. Should you install a version of MPLAB that we have not seen up to now, then you just need to ensure that that you update what's called the tool variable. So where are things installed? And there's a tool variable in here. It says here MPLAB IPE directory, and it's installed in this particular directory. So therefore, I've installed version 6.15. If you have a different version in, you just need to set that folder. And to set the folder, you just literally click on it. Okay. But it's 6.15. I'm using version 6.15 here, and I can just reassure you. Also, I changed to a different compiler or assembler, but I'll talk about that later on. There's value of doing that, but what I'm doing here is changing to PIC18xxQ4. Back into the program. From a build standpoint, we see no difference. Function key F5. It compiles the program and assembles it, generating the hex file. Then it says downloading program MPLAB IPE PIC18xxQ4 CLI for PIC using 5 volts. So now it's starting to talk to the PIC18xxQ4. It says it's found a small database. It's called a DFP, and those DFPs have all the configuration required for that particular chip. What just flashed past was a lot of information. It has the application version, the boot version, PCB version, etc., etc. It says something is supplying 5 volts. It found the chip. It told you the revision number, and it told you the device number. It erased the chip. It then tells you that the OTP, one-time programming configuration, cannot be programmed unless you do something. These chips support one-time programming, which means you can't reprogram them. You cannot reprogram them. If you set that bit, be very aware. Then it programs the particular errors that will be in the configuration, the memory, etc. And then it says, I've done it. And if we look at Deskcam, it's working. Don't believe me? Let's just do it once more. Function key F5. Once it starts to do the process, I'm going to flip out to Deskcam, and it says downloading. This will stop at some point. It's just downloading the firmware into the PIC18xxQ4. And it's the same for the PIC18xxQ5, by the way, and other programmers. It's now just picked up the DFP file that you've seen before. It's picked up the DFP there, and it's now erasing it and putting the program in. So overall, time is a little bit slower, but it still works. So you can use PIC18, PIC18, whatever PIC kit you want. And we saw this information in here, which is quite important. We saw the revision number in here inside of the IDE. We can see the revision number and the device ID. And in actual fact, that is the same information that you can see inside of here. Is when we pulled it up. It's 7A40. And if I just go back to the screen here, 7A40, very good. And it says it's revision 42. And as you can see, that's the revision number there, 42. And that sort of matches up with the data sheet. And if I now change back to the PIC18, which only takes a few seconds, I've done that already. I can then read that back using the software. So I'm actually reading the program off the chip back into the hexadecimal file. I haven't changed my programmer preferences, which I'll go and do next. But it's just read it back in, and this is the complete program sitting inside of PIC18 now. And there we go, it's sitting there. Back into here, function key F4, type in prefs, or edit preferences, choose your poison. I'm just going to put that back down there. And it's now back to my PIC18. Function key F5, it's working. And it's a little bit faster, as you can tell. Okay, great. Let's go back to PowerPoint. We've seen the sample code, we've seen the results, it works. Okay, next what we're going to do is take this little program here, we're going to add some serial values, and we're going to send those values out to a serial terminal so we can see what's actually going on inside of that microcontroller. Using serial as a debug tool is very, very useful. Enjoy.